Hello, this is Dr. David A. Gaitros, Department of Computer Science at Florida State University, and I'd like to welcome you to my undergraduate lecture series on selected topics in computer science. You can find these videos and others at my YouTube channel at the URL listed below, or you can simply go to YouTube and search using Gaitros and FSU as keywords. Now on to the lecture. Our next standard template library we're going to discuss is lists, and shorten this video a little bit. Lists are sequence containers that allow you constant time access to insert and erase objects, and you can do them from the front of the list or from back of the list. Now the lists are implemented as doubly linked lists, and as such you have real-time single access to any object in the list. You can go through the front or the back. Actually, it's better for inserting, extracting, moving elements. It's not so good for direct access because you have to iterate through it. So we're going to go over some lists, and I've gone ahead and populated this one. Let me explain the code to you. I have to include these two, the list and the iterator. The list to give me access to the template, the iterator to allow me to get through the list. We're going to do of type strings. I've got two functions I've written, one populate list and one print list, that allows me to put things into it and then to print it out. Here in my main routine, I've declared a list of type string, and I'm going to call it name list. And there's my hello world. That's what I start off with. Let me just change that to program finished. Alright. So let me go ahead and call populate list, and that works like this. I'm going to call it as I'm going to read in 10 items and push them back on the list. Now, note I can also push them on the front, or I can find a location inside the list and insert them into a location. Print the list. Well, I'm going to use an iterator to actually do that. I declare the iterator like this. I have to tell it that the iterator will track things in type list of strings. I'm going to call it MI. And then the first thing I do is I point it to the beginning of the list, and while the iterator is not equal to the end. Now this is different from vector, which I'm saying that the iterator is less than the end. Now I can't do that. Here I have to say it's not equal to the end. Remember that this is a doubly linked list, so the location of each record is not known. Alright. And then I just print out, and notice also too, since it's a pointer, to get at the location of it, I'm saying asterisk MI. So alright, well let's go ahead and call it. We're going to say populate name list. Okay, and let's run it, build it, and we're going to run it just to see if it runs okay. 1, 2, 3, 4, 5, 6, 8, 9, and 10. And program finished. Now then, let's go ahead and print the list. And then after we do this, we can actually play a few games here. We'll build it now. And let's run it. Oops. Nine and 10. Don't have to put 10, 10. There we go. There, we finished it out. So there's our code, and you can see how that works. Let me show you a shortcut. It has to do with this right here. Notice that we declared the iterator right here. Again, I'm going to make it an iterator. The iterator has to iterate through a specific thing, so we have to tell it what to go through. It says goes through lists of type string, but I can take this out. What I can do is I can go down here to my for loop, and I can say auto. Really a neat thing. So I can say auto MI. What it does is it looks on the right hand side of the assignment operator, finds out what that is, and then automatically declares that of that type. So that's an iterator because that's what begin is. Begin is an iterator for the list standard template library. Alright, well now let's go and do some other stuff. Alright, okay. and I'm just going to write the code. Don't necessarily have to execute it, but we may. Okay, I can remove things from the front and back of the list. I can say name list. I can say pop back, and I can say name list pop front. So let's see what that does. Let's build our list, and then let's go ahead and run it, and then we'll put in our standard strings here, so you know where 1, 2, 3, 4, 5, 7, 8, 9, and 10. Now, as you recall, we printed our list off. Let's go ahead and print it off again so we can see the results of that. Name list. Let's build the list. Build our program, and we will run it. Do it again. 1, 2, 3, 4, 5, 7, 8. Spell 8 right. 9, 10. And now you see, well, it took off number 1 and it took off number 10. Okay. Well, it took off number 1, and then that left 9 items, and then it took off number 9. It took the back one off first, and then the back one off again. We can also do pop front, okay, and pop back at the same time. Okay, so we can do pop back and pop front. Let's see what other things we can do. We can let's see, determine if it's empty. If name list empty, we can ask if it's empty. Okay, and see out something there too. Is empty. All right, is empty. Now you notice I mentioned the auto thing. Let's do that again. Let's say auto, and we'll say NBI for NLI for name list iterator is equal to namelist.begin. And again, there are several of these begin, end, reverse begin. You can reverse the list. So, and I can do things like NLI++. I can go to the next one, NLI++, or I can actually use that to search for a specific place in the list. Once I find it, I can actually do something like I can erase the list. I can say namelist.erase and pass it that iterator, and it will erase the item at that list. Now the other thing I can do is I can insert something. I can say namelist.insert, and I pass it the location of where I want to insert and then the value I want to put there. Alright, and if we were to run our list again, we would actually see all of the steps that I've just taken actually work out quite nicely. I can reverse the list. I can say namelist.reverse, and it reverses the contents of the list. And finally, if I just want to get rid of the whole list altogether, I can say namelist.clear, and it will clear the entire list out and print it out. You'll see that it's empty. Well, that's a very, very short explanation of a list. It's very much like our other template containers. Worth practicing and looking at. Hopefully in a future video I can show you what these look like in a C++ class. Hope you enjoyed this. Look forward to doing the next one. Have a good day.